Ladies and gentlemen, please welcome Mr. Andy Terrell.
Hello, I'm Andy. All right, so I'm here to talk to you all about the model review, taking a model from exploration to production. You can find this talk and some more details here at the this link, GitHub, a Terrel model review talk. While you're doing that, introduce myself a little bit. I am chief data scientist at REX, which is a real estate company in the United States, mostly based on AI. I'm also the president of Num Focus, which is an organization that sponsors about 50 different data science projects that span everything from R, Julia, Python, and kind of really focus on scientific analysis and helping scientists use data science tools. And this talk was put together by many others, calling out Andy Maloney and John Hanley, who helped me quite a bit, and the rest of my Rex data team. All right, so with no further ado, let's jump to this. If I can get this to work. All right, so you start off, everyone loves talking about modeling, and I want to start where everyone leaves off. The model's done, you've done some really great analysis, and you're set sail to blue ocean, and the world's going to make everything wonderful with your model. Except, as was pointed out by the 2015 paper out of Google, that model is really only one small bit of the larger complex analysis that goes around it in order to make your model actually very useful. So every time you see AI or modeling inside some big machine, like such as Google Now or the Uber buttons that give you the right price, or any part of that, you have to think the model that actually did that code is really just a very small part, especially in code, although it plays a wide role, and without it, it's just like your heart's very small part of your body. There's so many systems around it that you have to understand and take care of. So with that, let's chart our journey. First, let's talk about let's understand your model's deployment. Where is this model going to be run? How's it going to work? Let's track data into and out of your model. Like, how do you know what's going on into that model so to protect it so you don't have things that are bad going in your model and causing out of sample error and things that will cause other systems to really go crash and whatnot. How do you detect problems with your model in field, and also try to put together with some checklists that you can kind of review and take with your teams and kind of learn when you're producing your own models. All right, so understanding your model's deployment. First, so we talked about this nice boat. This is great before, but to most engineers, this is what they're going to put your model into, is a Docker container. Just like beautiful artwork, you take it to the shipping yard, they put it in one of these things. You have no idea what it is, and for a lot of folks, they don't want to know. They just want to know, I can move these boxes around and then hook up maybe something at the end of the day to pull whatever I need out of it and shove it back in, but it's a box to me. So let's break down what they're doing there. So first off, like, what's coming into and out of your model? You'll have to data sources, of course. I think that some of these pretty well understood, that you should know what data is going into your model, but sometimes I think that people forget to write down every bit of this. Some examples of these are like your application database, like which part of maybe your customer relations management tools or your web analytics tools. The number of places I've been where, like, oh yeah, we have some dependence on a Google Analytics type system that we didn't really document very well, becomes very challenging, especially as those data sources might deteriorate or be replaced by other systems. So just like you have to know what kind of power goes into your socket, whether you're in India or the US or the UK, you have to know what kind of data is coming in and how that data is going to maintain that data source. Another thing I always get my teams to do is talk about provenance of that data. And there's this great tutorial by Dongchong, who at on the GitHub there, and Don kind of shows out like just a tutorial of how you use what's called W3C Prov. W3C Prov has 3 pieces of information about any sort of object. It has the entity, the activity, and the agent. And so you can see in here this example, we have Bob wrote an article using the FTP OESM 11ST zip file, so this employment stats, and it appeared on this website. So from a very short snapshot, you can tell like who wrote the article, what data it came from, where did it appear, and those sorts of things can be done with any sort of model, any sort of notebook, and we'll show you a little bit about how we do that at Rex. And just kind of like redefine those provenance: entity, agent, and activity. Just entity of the physical concept, the activity, the thing that actually happens and occurs, the processing of the data, and then the agent, who's doing it, who's taking responsibility, who can you go find out like what happened here if something goes wrong. Another thing we talk about a lot in when we build out models and push them to production is turning contracts. So I received, my computer's receiving 120 volt wattage here, and it's not going to interfere with radio frequency. Those are contracts that we have in the electricity world. The same thing in your model, like you learn a lot of things about your model while you're building it, such as the range of your features, the distribution of your features, and maybe the sensitivity of those features to the variance and to other and to the outputs of your models. And you can codify those things and turn them into either inputs to your API or your whatever interface you're using, and use that in a pre-processing stage of your model. So now you can not only monitor how your model's predicting, but you can say, hey, all of a sudden, I'm a good example is if you have a face detection algorithm that you've put out and you're detecting sunglasses, and all of a sudden you say, uh-oh, my model, I see no more sunglasses. Well, maybe you look at the calendar and it's like, oh, we're in January now, at least over here. Nobody wears sunglasses in January because it's always gray and rainy, right? So that distribution of features can tell you certain things, or it could very well be that sometimes your model is not being predicted in the right spot. I certainly had a case where I deployed a model for a clothing manufacturer, and they stopped selling some of the clothing that we were modeling off of, and like there's a whole part of the model that just wasn't ever used, and we trimmed it down and got that out of there. And so just trying to keep it a tidy range and test things out. And in that same model, turns out we found that they're human bodies that were beyond the imagination of our models before, and so we had to catch some of those things and give an error somehow up to the application calling us and so forth. Okay, so we know our data sources, we know where they came from, we can tell a little bit about them when they come into our API or our interface, and we can give some appropriate ideas. But what is the actual environment going to look like? How does this model get called? What are some of the SLAs that you need to adhere to when you're thinking about how fast to go with this model? And then what are the systems monitoring the model to make sure it's working? What's its life support systems, if you will? I love this book, Software Architecture Patterns. There's a whole bunch of different architecture patterns, a very thin book by Mark Richards. And here's the one that's probably for most web APIs. You have clients calling in to some interface layer. There's a whole bunch of different modules and components put together. And in the middle, REST is kind of the standard API thing that's used today. GraphQL is kind of coming on and taking that on a little bit, but it's always moving pieces. So, all right, so our model is going to be one of those blue modules in there because we're definitely not the user interface layer. We're definitely not all the components. So straight off, our model is going to be wrapped up, and we're going to be at least 3 layers away from the actual client request. Oh, but then there's this other side, which a lot of people use, called the Lambda architecture. And Lambda architecture is a different kind of view of like, well, I'm going to have a lot of data coming in. I just want to batch process. So in here, my model is actually up at the top in my batch layer where I bring in a lot of data from a data stream, and then I batch process it and then put it into what's called a serving layer, the actual database, perhaps, that's going to be like showing the client what your model predicted. And in this case, the client isn't ever calling you directly. They're just seeing the aggregation of the batch view. But often what will happen is that you need some faster layer. For example, if you're in the ad industry, we want to calculate real-time values of how much ads we're spending on a single user, for example. And that might be a table that gets incrementally processed very quickly. And the real-time data might check against that aggregate. So I could certainly have a case where I have a model coming in about a user and their web flows and pre-computing to bid on an ad for that user, and a process stream saying, hey, you bid on a lot of ads for this user, and he's probably tired of listening to you. And then that merge will then say, oh, okay, don't show that. So in this case, you actually have three models going on. The batch layer, which is actually maybe a deeper model that's going for all your data. The speed layer, which might be a very simple model, such as average or count, soft max, or something like that. And then the serving layer that actually merges those things together. And so where your model lives will depend upon what your speed layer is and like what your SLAs are going to be of that system. And so that's another mode that a lot of people serve. So here's a model that here's a architecture diagram of a model I put out with a clothing company a long time ago, and it's like, all right, not only do I have to have like the different views, and so this was the first view, like someone calls us and then we would just call the model and respond, but who's monitoring this thing? So just on nodes, so we have like an AWS load balancer come in, we have the EC2 instance, and then in there we have several different pieces of software with those Docker containers, those big containers we can shove into any two instance. But in there we have these arrows going off to these red trails where I have run scope, which is something that pings my model and says, are you still alive? Are you still alive? I have SendGrid, which is an email notification like, hey, I just had this really wild error bar come through. If this happens 5 times again, I really want you to check it out. And then I have like roll bar, which is in Sentry and some other things out there that help you detect any errors that happen while you're inside the models. Those they can categorize them up and so forth. And then over here, I have Papertrail, which just gathers all sorts of logs and gives you a nice, just like Splunk, a nice way to deep dive into like what happened into the system. And so this is a real live system we put out. And then, in here you see data model way down at the bottom, and all these systems kind of up and around them. All right, so you thought you were in open ocean, but turns out you're stuck in this morass of ice everywhere, and you needed a different ship. It's okay, we're there with you. So how does this work in practice? We write it straight up in code, like our ETL process, our extract. We do this kind of nice feature where I say I'm going to start extracting different types of data. I'm going to create an extract method, and I'm going to actually do this kind of trick where we subclass it so I can just define the underscore extract on any sort of data processing layer, and then I have my extract piece. The transform is the same sort of a thing, but here when I transform my data, extract, usually I'm taking it from a place. Transform is taking it from the raw, and then from the raw format to whatever format I might need for production and so forth. And then load, like this guy is the one who's in charge of doing all the different bits, so like both the extract and the transform. So we have the extract transform load that will eventually create a data set. And here's an example of our CSV data set. And you can see we have a whole bunch of different places we might put this data set, and even kind of create on S3 or some object store system and whatnot. So from a very get-go, we're creating hierarchies that can call into each other and kind of understand how to put. Also very good at a caching layer and so forth. And here's another example in the code you can. Does this work in practice? Here's the iris data set where we're coming through the standard iris where we extract the data from just a read function. We come in here, we actually get our targets named and to find the actual features we need. And then we load that into whatever data frame that we're actually going to use in production. And you can kind of put that into practice. In that, you'll see when I come to work with people about like their data, like you say, all right, so you did that, all that work to get your Irish data frame. I want to see whenever people show me their models, I want to actually see, show me how it works. Is it actually working well? Can I see separators in your data? And the Irish data is very nice because it has those things. And Seaborn has a whole bunch of different plots, such as these distribution and joint plots to kind of show you that. And there's also tools like Bouquet, which give you more of an interactive view. It's a lot more code to get Bouquet working, but it has, as a dashboarding framework, which I use in almost every company I work with, it's been super valuable to see in a live stream of data coming through. Always know pandas for predictions, show correlations. Pandas profiling is another great way to like get into that data and learn about those ranges and so forth. And then like another technique that I think everyone should do, but I don't think they always do it, is to actually profile what happens if I'm missing data when it comes through, and how's it going to affect my model. And so here, this actually isn't quite in the GitHub just yet, but I'll have it there by tomorrow. But here, if you just take like a very simple simple impute function, if I erase a whole bunch of my data and then see how does it change, so you can actually see like, all right, does my statistics actually change in my data? And furthermore, if I just profile only those missing data, does the same thing look do I get a very similar looking correlations, or do things kind of change dramatically? And in this case, you can see if you go through these slides, you can see like this one here changed, no longer really has a separator once you removed all those data points. And there's a whole bunch of different ways you can pull this out, but sometimes the mean one doesn't work. So you might do something like k nearest neighbors, which really changed my separators. And so you can play with some of the imputation stages and like get to know what's going to happen in real life with your models. We're kind of going over time, so let me. As a checklist, I always tell people write down your meta model, put your objectives, your KPIs, tell us what it's predicting, how we're going to know if it's out of sample, and so forth. And if you go through here, the whole checklist is down throughout this whole the whole kind of a process in order to prepare your model for production. Sometimes your model goes down. I know it happens, but it's tough. What I just kind of say with that is like define your health checks and your alerts. That thing I just showed you, this was the system that actually, there's only four different actually client-facing models. One, that API, which you saw earlier, is the only piece that was the actual data model. And of that, over half our system was built to just monitoring that thing. And so often what you end up doing is actually doing a lot more work to make sure everything's working appropriately. Also, I love these new model servers like Bento and MLflow and Redis AI that's kind of come out. Always once you get it all done, you can do it again, and you have a whole fleet of models to deploy.